Hello, this is Pat Kelly. In this problem, they ask us to find a piecewise smooth parametrization of this path. So you can see where this path is coming up the pink first. See the arrowheads hitting this point 1, 1, and then kind of arcing back. And they also tell us the equations, the functions of x for each of those different legs of our journey. I'll kind of stress that word just because, stress the word legs there. Just because the directions even said to find a piecewise smooth parametrization. And so the idea of the piecewise part of that is you just attack each of the legs separately, okay, in order. So let's do that pink leg first. All right, so let me get ready for my answer here. R as a vector of some parameter t is going to equal. And then for that first leg of the journey, you imagine the particle just traveling right up that pink path where y equals x. And then what you want to do is think about what your x's and y's are doing during that path. Specifically, I'll think about the x's. The x's are starting at 0 and ending at 1. I start with thinking about the x's because in this case, y is a function of x, and in this particular leg, y is doing the exact same thing as x. Okay, so first get a handle on what x is doing. It's going from 0 to 1. Right? And the way that I'm going to represent that with my parameters then is just t times that I vector. Okay. Then I'm going to leave a little bit of space. I'm going to come back and fill this in. But for my piecewise function, I want to have a statement about what that independent variable, the parameter, is doing. So this is one of your restricted domain statements over here. And I'm going to let t go from 0 to 1. I had to write that down as we're talking here because you need to know what t is doing in order for this to make sense to you, that x is now doing what we want it to do. T goes from 0 to 1, x goes from 0 to 1. Okay? Now the y, as I mentioned in this pink leg, is doing the exact same thing as the x's, so my y component is also going to be a t, but this time times that j vector. All right? So there's your first leg of the trip. The second leg of the trip is going to be a second branch of your piecewise function. Remember they said piecewise smooth. We represent each leg of the journey with a different branch of the piecewise function. All right, in order to get the next branch laid out algebraically, I definitely want to have a handle on that restricted domain maybe earlier rather than later. So I'll start with that. So I'll say comma. And another word that was thrown in there with the directions, the smooth part, that's easily handled by just letting your second branch pick up with the t values where the first branch ended. So if this ended at 1, let's start at 1. And I'm going to let t go from 1 to 2. You have a lot of flexibility in what t is going to be in your problem, but I think these make sense to me. 0 to 1 and then 1 to 2. And with those values of t in mind, let's figure out how to write this algebraic expression with the same kind of thought process as we did with the first leg. That is, what are my x's doing? First, my x is going to start at 1 on the blue path, and then I have to get down to 0 on the blue path. Okay? I think this works if I do 2 minus t and make that the coefficient of that I vector. What else I'll suggest is you check yourself pretty frequently and see if that does make sense to you, if it does work. So if I put in my 1 for t, 2 minus 1 is 1, that's where I wanted x to start. If I put in the 2 for t, 2 minus 2 is 0, and that is where I wanted the x to end. Okay. All right, I focus so much on x now then because in this case the y components, the y coordinate is a function of x. So you have your independent variable, x, and you can see what your dependent variable is in this case. Y is equal to the square root of x. So I'll just come over here and write that y as that function of x, square root of 2 minus t. I want you to see that as square root of x, and we knew what x was. And you're done We just need that j vector in there. That's your parametrization of this path, okay? Hope that thought process helped, but you really need to practice some more on your own to get a hang of it. Go to it.